Welcome to a new lecture of industrial drawing. This time we're going to face how to indicate the dimensions on a technical drawing.
To begin with, I strongly recommend to read the standards for dimensioning correctly. These are the parts of a dimensioned line. The most important ones perhaps could be the dimension text and the dimension line. Now let's see a few tips about dimensioning. Dimension text always indicates the real measurement. Every dimension should be placed in the most suitable view. Try to place dimensions out of the view. No lines should cut the dimension line. Use extended lines for chamfers and fillets. Never break the dimension line in breaks. For dimensioning arcs, if you know the center of the arc, the dimension line has to begin in that center. Be careful with the dimension text orientation. Try to place always the figure over the dimension line in a centered position, else in a left side, else on the left side of the dimension line. No dimensions with hidden lines and use sections. Be careful with sections in profile views. In this case, the circle seen in a profile view is seen as a line, so we must use the diameter symbol before the figure, before the measurement. We have to take into account manufacturing processes when dimensioning. We can see in the figure the small vertical line must not be dimensioned because it's a resulted line from the manufacturing process. When dimensioning holes, we must dimension the center of the hole. It's not necessary to repeat dimensions of repeated features. In this image, we can see that the 5 mm diameter holes are only dimensioned once. Angular dimensions can be avoided if they are not necessary. Try to dimension in an aligned way, and you can use whole simplified dimensions when the circle is very small. We have different ways for dimensioning chamfers. Now let's see two common operations with dimensions in industrial drawing. First, let's see the linear dimensional chains. Imagine we have to dimension D block to be inserted in between A and C. It's quite easy when we know all the dimensions. The resulting D in this case is 20. But it becomes a tricky question when we have tolerances in the dimensions. We have to follow a method which is called linear dimensional chain. Let's assume D has a tolerance and we need a 0.1 clearance between the blocks. We can create a linear dimensional chain, which is a set of independent parallel dimensions which continue each other to create a geometrically closed circuit. We turned the dimension lines into arrows to follow the direction of the chain. So in this case, we can create an equation with the measurements. So C plus 0.1, which is the clearance, plus D plus A equals B. The first thing we have to do is changing the values of the dimensions to be symmetrical. Now, to solve the chain, we can use the worst case method or statistical methods. We'll use the first one. We have to use the extreme values for a minimum clearance. The minimum clearance gives us this equation, 0.1 plus the maximum value of the D plus the maximum value of A plus the maximum value of C equals to the minimum value of B. That means the maximum value of D equals to, in this case, 19.3. So we can get the value of D with the tolerance. The second operation is called transferring dimensions, and it occurs when we want to change a dimension due to functional aspects. For instance, we want to change the B dimension by C dimension. We don't have any issue without tolerances. We could change the 15 dimension by the 25 dimension. But with tolerances, it's not so easy. In this case, we cannot add upper deviations and lower deviations to get the final, in this case, 25 plus 0.5 and 25 plus 0.1. That's not correct. Why? Well, if we added or subtracted tolerances, we could get these values. Imagine C is 25.05 and A 9.9. That means B equals to 15.06, which is impossible due to the tolerances given previously. So, how can we deal with this kind of problem? Well, we have to follow a method. First, we're going to check tolerances. We're going to substitute the one with the bigger tolerance. In this example, the tolerance of the 17 dimension is 175 microns. On the other hand, the tolerance of the 32 millimeters dimension is 65 microns. So the substituted dimension is the 17 millimeters dimension. Then we are going to follow this equation. Substitute dimension equals to the one kept in our drawing minus the new dimension. Applying that equation, we get the maximum and the minimum values. So in this case, the maximum value of the S equals to the maximum value of F minus the minimum value of the new one. Minimum value of the new one equals to the maximum value of F minus the maximum value of the S. So in this case, we can get the minimum value of the new. Applying the equation for the minimum value of the substituted one, we could get, in the same way, the maximum value of the new one. Okay, that's all for today. See you in the next lesson.